Well, now we return to the study of confidence intervals, and we will move on to actually look more in depth at what the confidence interval is and how we may begin to calculate it. To develop a confidence interval for an individual data, the following slides demonstrate the methodology for constructing that interval for a population when mu and sigma are known. Now, of course, we never know mu and we never know sigma, but this is to help you grasp what you need to do. What do we know about these data? That we know that 100% of the data are under the curve. And what about the standard normal curve? Well, 100% are under that, and just like they're under the other. Now, if we want to capture 95% of the data in the standard normal distribution curve, we would establish boundaries centered on the mean based on z-scores of plus or minus 1.96. This 1.96 above and 1.96 below traps 95% of the data. Our confidence level is 95%. Our error is 5%. C is 0.9500. Alpha is 0.0500. C stands for confidence, and alpha stands for error. You will note that our error is split in half. We have half of it below the mean and half of it above the mean. Where you have error on each side, it is generally called a two-tailed test. Confidence intervals utilize two-tailed distribution of the error. Now, if half the error is below and half the error is above, then on each end we have 2.5% below and we have 2.5% above. You will often hear statisticians say something like, well, there's 2% chaos above and 2% chaos below. That's the normal distribution, 2.5% on each end. Our error is two-tailed. That means that it's split in half, below the mean and above the mean. Now, for the standard normal distribution curve, a given percentage of data can be trapped using mu minus the z-score and mu plus the z-score to establish the boundaries. I want you to notice that we have done a confidence interval at a given percent, and we have established boundaries. The boundary might be here and here. The boundary might be here and here. It depends on the level of confidence that you desire. Now, here again is I've given you the confidence interval table. The critical values of Z confidence, you notice that we call that Z confidence, for 70% or 1.04, 75, 1.15. Most of the time, we're going to be using confidence levels of 90%, 95%, or 98%, sometimes 99%. Confidence intervals below 90% are seldom ever used. Well, we can update our notation. We would establish boundaries of confidence interval would be mu minus the z critical and mu plus the z critical. This is for the standard normal distribution curve. What about the normal curve? What about one that is in terms of mu, where mu has a value and we have one standard deviation above, two below, two above, one standard deviation below, and two standard deviations below? We would establish our boundaries using mu plus or minus z confidence times the standard deviation. So many standard deviations below and so many standard deviations above. That gives us this formula. Our confidence interval boundaries, the lower bounds, catch that, the lower bounds is mu minus z confidence times sigma, and the upper bounds is mu plus z confidence times sigma. This is really not very difficult. And we use the z confidence levels that we were given in our tables. Once we extrapolate those, they are forever. This 90% is 1.645, 95% 1.96, 98% 2.33, 99% 2.58. Yea, verily, those values are written in stone now. Here we have a summary. Confidence is the likelihood that an event will occur. Confidence is represented by C. The error is the likelihood that an event will not occur. The error is represented by alpha. Now, our confidence plus our alpha should add to 100%. Our given levels of confidence can be represented by z-score boundaries noted as z-confidence and can be extracted from a table list. And the formula for a general confidence interval, just for the normal distribution curve, the confidence interval, the lower bounds is mu minus z-confidence times sigma, and the upper bounds is mu plus z-confidence times sigma. Now, you keep climbing the ladder. You've got this. You're going right on up. You're on rung 3, and you're headed for rung 4. You're going to master this course. You've done well.